What kind of phone are you using to send these with?
My iPhone. My camera's not exactly the best.
Well, make sure you send them as large images, not small.
I did send them as large.
Okay. For some reason, are you seeing my screen?
Yeah.
Okay. Now let me see what happens if I download this. It's the first time I've ever seen it sent as an ASPL program.
Oh, that's my uh on my email. That's my signature. Part of my signature.
Well, notice that here, let me see if I click on, okay, yeah, this will work. Yeah, hold on a moment. I think I'll be able to read this. Where do you want to start? Which question?
Um. Okay, any are good.
Well, always, whenever I get that, I'm going to start at the beginning.
All right.
All right, let's see. Well, so this Ricky Lake, used to be a famous person, goes on a diet and doesn't say what her initial weight is, but after 4 weeks, she weighs 202, and after 44 weeks, she weighs 122. So she clearly is losing weight. What's the independent and dependent variables? What's the
Uh,
independent? What's the independent variable?
the independent variable is the weeks.
Yeah, what's the dependent variable?
Weight.
Yes. And that can be a little tricky. In other words, I'm always a little bit confused myself. If I tell you y is equal to 5x, well, x is the independent variable, y is the dependent variable. But what if I switch it around all of a sudden and I got y over 5 equals x? Well, now y is the independent variable and x is the dependent. So I kind of hate that terminology, independent and dependent variable. I just don't like it. Maybe because I don't fully understand it. I don't know. Write two ordered pairs which describe this situation.
Um. 44 to 44 122 and 4202.
Correct? Write an equation which relates these two variables.
So you find the slope by finding the difference in the 2 points.
Yeah, that's a good start. Hold on. So we have 2 points, first of all. One is 4, 202, and another one is 44, 122. Well, if I told you you had an xy coordinate and you had those 2 points on them, come up with the equation of that line. And you're correct. Slope is the first thing. What's the slope?
It's changing y over changing x, so 202 minus 122 over 4 minus 44.
Be careful with your signs. Oh, no, you were correct. 4 minus 44. Simplify that.
Um, negative 40. So that's 2.
Negative 2.
Negative 2.
And that matters. In
Yeah.
other words, this is a slope that is negative like that. In other words, the more weeks you are on the diet, the lower your weight's going to be. Thank God she didn't go 88 weeks. She'd have disappeared. Okay, so we have a slope. We have 2 points. How do we come up with an equation of that line?
Well, since you have your m, you can set it up as y equals mx plus b, and then plug in one of the points in order to get your y-intercept.
Okay, tell me what to do next.
All right, so you have y equals negative 2x plus b.
Okay.
And then take, say, the point 4, 202. So you have 202 equals negative 2 by 4 plus b.
Correct.
Then add 8, and you have 210 equals b.
So what's the equation?
Y equals negative 2x plus 210.
Very good. All right. Hold on. What's the slope? What you've already come up with that, minus 2. What's the real world meaning of that in this context?
2 pounds every week.
Yep. What's the y-intercept?
The weight that she starts, the weight that they start at.
Well, the y-intercept is 210. And the real world meaning of that was you're correct. That's what she would have started out at. Notice they never gave us that. They told us what her weight was after 4 weeks and again after 44 weeks. So they didn't tell us what she started at. But that's the real world meaning would be that's what she weighed at the beginning. How much did she weigh at 30 weeks?
Just plug it in, so y equals negative 2x plus 210, so that would be 180.
30. Plug in x of 30.
Oh, yeah, so never mind, so that's 60, so that would be 150.
Okay. How many weeks will it take until she weighs 170 pounds, and how do I set that up?
170 equals negative 2x plus 210.
All right. Trust you can do that. What is the X-intercept? Does it make sense in this situation? In other words, here's a curve. Go ahead and draw it. There's 210. There's a slope of minus 2. What would that mean? What is the X-intercept, first of all? How would I get it?
Where y equals 0. So
Okay.
it would be how long it would take for her to reach 0
weight.
0 weight, yeah.
Okay, how long is that? In other words, if you substitute 0 and solve that equation, what do you get for x?
I'm going to set x minus 0. So all right.
105, right?
I think so, yeah.
So if indeed she continued to lose weight at 2 pounds per week, well, at the end of 105 weeks, she would be down to nothing. That's what the real world meaning, oh, well, it doesn't actually ask that. It says, what is it? 105 weeks. Does it make sense in this situation? No. What's really going to happen? What's really going to happen is this. She's going to drop weight and then level off, hopefully, at some standard weight for her, something like that. So in reality, for the first 44 weeks, she may drop weight linearly, meaning every week she drops 2 pounds. But in reality, what happens to people is when they get down to a weight, they stop losing it at 2 pounds per week and they level up. Hopefully they don't go back up. Most people end up doing that and going on diets repeatedly their whole life. So in reality, this is probably not a linear curve, but some sort of curve that has a function defining it. Let's see, number I, list 2 other ordered pairs for this situation and explain their meaning. Okay, well they gave us 2 ordered pairs, and the ones they gave us were 4, 210, and 44. What was the rest of it? What'd she weigh after 44? 150?
122.
150?
122.
Oh, 122. She really got skinny. Okay, and our equation of the line was this. So give me 2 other ordered pairs. That being 2. How about 2 others? Always pick the easiest numbers to figure. In other words, what you have to do is come up with 2 x's that aren't 4 or 44 and figure out what y is. Well, what's a really easy one to do?
1.
Okay?
Or 0. Or, no, you already have
0 is an excellent one to do. What do I have wrong here? What was her starting weight? Or what was her 4? She weighed 202. I got this wrong. That's 202. So 0 is a very good one to use because the calculation is very simple. And what's another one?
1.
What'd she weigh at the end of 1 week?
208.
So what's the hold on. Explain their meaning. So the first order pair means what?
First ordered pair is what she weighed at the beginning.
Before she went on the diet? What's the second one?
Second one is after 1 week she lost 2 pounds.
Right? Or she weighs 208.
Mm-hmm.
And finally, what are the domain and range of this situation? Not function, notice. Situation. In other words, here's the function. What's the effective domain? And by effective, in other words, we can see that if we just look at that as a function, the domain is all real numbers, right?
Yeah.
But in this situation, x clearly can't be negative, right?
Mm-hmm.
And what's the maximum it can be? $105.
Okay.
And that's not even realistic. But it certainly cannot be more than 105 because at 105 weeks, she weighs nothing.
Mm-hmm.
There's no way x can be greater than 105. And you could argue, well, it has to be a lot less than 105, but we wouldn't know where to draw that line. In other words, we don't know if it's 44 weeks or 64 weeks. Obviously, at some point, as she starts approaching 0, she's going to stop dieting or she's going to die. But when they talk about domain for this situation, these really are the only two numbers that make sense. The 0 is when she starts the diet, and 105 weeks would be the absolute maximum she'd be on the diet. She'd die after that. What's the range?
Y is greater than 0.
Well, in order to figure out the range, when you have a domain of a situation like this, to get the range, just plug in these two values and see what y does. So when I plug in 0 for x, y is at 210. When I plug in 105 for x, y is at 0. So what's my range?
Y is greater than 0 and less than 210.
Give me an interval. Yeah, 0 to 210. Have you gotten to interval notation yet?
No, we haven't.
Oh, you haven't?
No, we use inequalities.
Okay, you'll get to interval notation really quick. Let me just give you a primer on it. Let's say something could be between 0 and 2 or 4 to 7. Okay? Well,
Right.
if I was going to give interval notation, that's the x values, well, I would put it like this. And I would use this sign here, meaning in combination with this. Okay? So that's interval notation for those two intervals. And a lot of times when you solve some of these inequalities particularly, you'll have 3 intervals. And so this sign right here becomes a better way to state that than saying, you know, y is greater than 0 and less than 2, or y is greater than 4 and less than 7, or so forth and so on. So at some point you'll get to interval notation, and let me make one other note about interval notation, and that is, we know that x can be 0, right? Why did I write 2? That's not 2, it's 102, right?
Mm-hmm.
We know that x can be 0. So I don't really put a parentheses on that. I put a bracket. If it can be 0, then you want a bracket. It actually can never be 102. At 102, she's dead. She weighs nothing. So theoretically, it could be any number between 0 and 102, but not 102. So I use a parentheses there. Oh, I know why it was 2. I was just making this problem up. And in our case, it was whatever. But the distinction between a bracket and a parentheses is just that. If the x can be the value on this end of the interval, then you use a bracket. If it can't be, use a parentheses. Now, if infinities always go with parentheses. If I just told you y equals 2x plus 3, the domain of that function is minus infinity to positive infinity. In other words, there are no restrictions on it. X can be anything on the domain. Same way with y. The domain would also be minus infinity to positive infinity. But that's a little different. If I give you the function y equals square root of x, now the domain is 0 to infinity, and the range is 0 to infinity. In other words, x can never be negative, and y can never be negative.
All right.
All right, let's take a look at this bottom word problem. Is your dog or my dog?
That's my dog.
Yeah, no problem. I just couldn't tell the difference. So when you do a word problem, very first step is always, always, always A. Define your variables. Well, how do you do that? You usually go to the very last sentence. What are my variables going to be? X equal what? And Y equal what?
X is the amount of adult tickets, and Y is the number of child tickets.
A number of adult tickets. And it's important to put this symbol here. The reason being is that there's two things associated with an adult ticket. There's the number of tickets that were sold, and there's the price on them. So if you just say adult tickets, that really is not enough. You always want to specify what it is. It's actually the number of adult tickets sold. And Y would be the number of child tickets sold. Now at some point you don't need to write all those words out, but the key words are that and that and that and that. Because we have to distinguish between the price and the number. And notice that that final sentence says how many of each type of ticket were sold. So we're talking about the number of adult tickets sold. Okay, so give me an equation using these two variables, knowing that I need two equations, right? In other words, if I only come up with one equation, I cannot solve it if I have two variables. What's one equation?
X plus Y equals 848.
Good.
And 9x plus 6y equals 6,711.
You have any problems at all solving that?
No.
Almost always you want to use elimination in these kind of problems.
Mm-hmm.
Because by the time you write your two equations, they're in standard format, which is to say X and Y are on the same side, the numbers on the other. And whenever you have two equations in standard format, guarantee you it's always easier to solve them using elimination than it is substitution. We have 2 minutes. A number, I won't go over 2 minutes because I got a 4 o'clock, a new one, so I got a caller. What are your variables in number 5?
Number 5,
Look to the last sentence. You don't even need to read the rest of it. Just automatically go to the last sentence.
All right, yeah. So X is the number of packs of gum. Y is the number of bags of popcorn.
What's that last sentence say?
Oh, how much did each item cost? Okay. So
X is the cost.
Okay, so yeah, so X is the cost.
Gum, and Y is the cost of a bag of popcorn. That's where it really becomes important to distinguish between cost and number of items. And I love these two problems being back to back because it really illustrates the difficulty. So, and it's really, really easy. Just always read the last sentence. The last sentence will tell you exactly what each of your variables should be.
Okay.
All right? All right, I'm going to let you go, Cole. I will talk to you next Monday. Glad
Talk to you next month.
Doing well.
Yeah.
Have a good week.
You too.
Bye-bye.
Bye-bye.